Technical sports such as tennis, fencing or golf require several thousand exact repetitions of the same movement throughout training. Correct analysis and precise feedback requires expertise which is not always accessible due to time, geographic or financial constraints. Our goal was to engineer a lightweight smart coach using 2D pose estimation, which is able to predict a variety of fencing movements and their error patterns. In the absence of a suitable dataset, we collected and published more than 1,200 videos featuring 4 main fencing movements and a collection of corresponding error patterns. To establish a benchmark on the collected dataset, we trained a variety of machine learning models capable of extracting spatiotemporal features such as LSTM, CNN by LSTM and attention-based models. Our research has shown that fencing movements can be correctly classified and corrected with a high precision.
There is a growing number of possible journals, and every journal has its specific area of expertise. Therefore, one of the challenges scientific authors face when they want to publish their work is choosing the right journal. Recommendation systems can help making a successful choice easier. There are several ways to build such a system with artificial intelligence. In our approach, we use data from the areas of physics, chemistry, and biology. For each discipline, we worked with a dataset of 750,000 publications. From each of these publications, we used the abstract and journal name. For our purpose, we used ELMO as feature engineering and built our models by using convolutional neural networks and recurrent neural networks. We evaluated the quality of our models by using the metric accuracy. From the 6 models, the one built with RNN by using data from the area of physics has achieved the highest accuracy. Thank you for your attention, and we are happy to discuss our approach with you in person in SDS2023.
Blinkist, a subscription service that provides book summaries, was aiming to increase their user engagement. To achieve this, they wanted to create relevant and personalized recommendations. Our solution crawls trending news across multiple countries, pre-processes the news, matches it with a corresponding book using a nearest neighbor algorithm based on verb embeddings, and generates a recommendation text using GPT-3.
Previously, Blinkist's editorial team was manually preparing recommendations based on trending news for their users. In a team, we developed a recommendation engine that sends out personalized newsletters based on current trends at the user's location. The recommendation engine outperformed human recommendations by 10% in content engagement and by 15% in users saving the content for later reading. It not only reduced the editorial team's workload, but also won the Best Data Application Award.
The project presented here is a collaboration between the Lausanne University Hospital and the Swiss Data Science Center. Sepsis is a serious condition that causes millions of deaths every year. It occurs when the body response to an infection is so severe that it starts injuring tissues and trigger organ failures. Since anyone can develop sepsis, early recognition and treatment is critical. To better capture and document these events, we have created a dedicated data pipeline where information from the patient's electronic health record is processed and stored in a knowledge graph. This modular database is then used to compute key performance indicators, monitor quality of care, and give targeted feedback to nurses and physicians. This in turn allows for an improvement of the sepsis care for the global inpatient population.
This pipeline queries the data from the data warehouse and use it for different goals. The first goal is to feed an interactive dashboard. The second one is allowing us to access the data for ML approaches. The third one is to enrich a graph database that we're going to use for the machine learning approach also. All of that allowed us to have some preliminary results. And as you can see on the curve, it's very encouraging. You can see that the sepsis probability is correlated to the ground truth given by the clinician. So the next steps are first to perform a manual review of the model, and then to deploy this model in order to analyze the past in several units at the hospital.
Transforming text documents to graphs using natural language processing to fight financial crime. Let's start with the motivation for this project. Imagine you're a financial investigator tasked with investigating the activity in this suspicious activity report. This is a very verbose document and it has all the information you need, but it can be hard to process. What we propose is to automatically transform that document into a graph representation that captures all the relevant information visually, and it also enables graph analytics and graph machine learning to aid in your investigation. The methodology for doing this is a natural language processing pipeline we built, which starts from the sentences in the text. It extracts the entities from those sentences. It finds the relations between those entities, and it resolves the coreferences between those entities to build the graph. The key technology behind this is pre-trained language models, which can represent natural language in a vector space that captures all this information, and we can use those to find the entities and the relations in the text. We built a demo for this that accepts text from the user. It clearly highlights the entities and relations detected along with the core reference clusters, and it builds the graph for visual inspection and analysis. Come and see more details at our poster.
Welcome to my show presentation about our paper called Video Object Detection with Temporal Consistency for Patient Monitoring in Intensive Care. In the ICU environment, we'd like to prevent false alarms from putting too much pressure on our clinical staff. And we achieve this by creating an object detection model that can run efficiently on standard hardware and that can deal with blurred videos. And we achieve this by repurposing our RGB channels from the input with grayscale, the pixel level difference to the last frame, and the visualized bounding boxes from the last detections. Overall, we see 10 times faster convergence in training time, plus 1.7% in mean average precision, and we see a lot of potential in this method, and it is applicable to any given object detection model. Thank you.
Hi, claims handlers at a large reinsurer can only review a fraction of all claims. What if these highly skilled employees could focus on only the most complex cases where they can add true value? Our experts are now enabled with a claims triaging application that has a machine learning model at its core. So claims handlers can pick up claims with a high impact likelihood. They will review this claim and the decision stays with the human. To better understand the model, we first used global model agnostic methods for explainability. These were insightful to our domain experts, but the individual predictions remained unclear. To increase the transparency and the trustworthiness, we added local explanations. And we saw two categories of benefits. One, there's a feedback loop to data scientists, which improved modeling and feature engineering. And two, predictions were interpretable, and so users can truly engage their critical thinking. And questioning a model is very important in the settings where we are using them. Come visit our poster to learn more.